to just quickly look at a couple of applications of exponential functions. And this whole first page should look super familiar to you if you ever took Algebra 2 in high school or MA 102 at Bellevue University. All the same idea. We're looking at a formula that's already been written for us. And this is an interest that is compounded n times per year. So for instance, looking at my first example, I have a principal of $10,000, that's how much I'm investing, with 5.5% interest, which I would write as 0.055, compounded monthly, so that means 12 times per year, and then for t equals 1 year, because t is always in years. So essentially what I'm doing is taking this function, plugging stuff in, and then using my calculator, which doesn't take it rocket scientist, right? And then instead, if I did it daily, notice daily means 365 times per year, or 365 and a quarter to be super specific. We just use 365. So notice I've replaced 12 with 365, and it would make perfect sense that I would make a little bit more, because when I'm compounding, I'm taking the interest that I've earned and it's going back into my principal, so I'm earning money, more money, because it's based on a higher principal. So that's how it works. So again, that should be pretty straightforward. Why I'm talking about this in a calculus class is because I want to talk to you about what happens when we compound continuously. So again, let's take a look at the calculus now involved in going from a function that looks like this to a function that looks like this. Because if you took MA 102 or took Algebra 2 in high school, you were just given the fact that the formula for interest compounded continuously, which means all of that interest continuously just goes back into your principal, which is of course the best way to go if you're investing money, but not so great if you're borrowing money. We're going to use theorem 5.15. And essentially what that says, and then we're going to go through this math together as to how we did all of that. What this says is that if I take the limit as x approaches infinity, now in our case that means as the number of times we compound gets larger and larger towards infinity, of 1 plus 1 over x to the x, I end up with e. So we're very familiar with e, the natural exponential function. So let's take a look at the math involved in taking principal times 1 plus rate divided by number of times you are compounding to the number of times you're compounding times the number of years. How does that all of a sudden turn into the PERT equation that we use? Principal times e to the RT. Well, the first thing I do is just take the p and pop it to the outside. So that one's very straightforward. That gets us to here. Now what I'm going to do is just a little bit of trick math, math magic as you know I like to call it. And I'm saying, okay, well I really kind of need this to match what I have here, and it doesn't right now. So let's rewrite r over n as 1 over n divided by r, because we know that's the same thing. So I didn't change anything, I just fiddled a little bit. So now we can consider this guy as x, but now I need my exponent to be 2 the n divided by r. Well, how does that work? If I had n divided by t, or sorry, n times t, then it's okay for me to move the t to the outside, like that. And then, am I really doing anything wrong if I take it divided by r on the inside and times r on the outside? Because really what I'm doing is taking that times r over r, which is 1. So I haven't done anything illegal mathematically. So this is my new and improved equation using math magic. Well, now as you can see, it does fit this format. So I can replace all of this guy with e. So that's where I get p on the outside, all of this guy is e, and then to the RT. So that's where that formula or function for interest compounded continuously came from. So again, the types of questions you will get will not really be calculus questions. They'll be questions like you had in MA 102. Let's look at the interest. If I invested $15,000 for 20 years, compounded daily, so 365 times per year, versus compounded continuously at 6%. So I'm going to let you press pause here and try this question. When you're done, press play to see how you did. Again, this one's super straightforward if you know the two formulas, and the two formulas are, this is for compounded however many times per year, this is for compounded continuously that we just talked about. So really I'm plugging things into the appropriate place. In this case, n is 365 because it's daily, and then for the other one I don't need an n because there is no n, it's compounded continuously, and I'm just utilizing my calculator. So we can see even over 20 years, I'm only earning $491 more by compounding continuously. And that's because n was 365. So if this one was compounded, say, yearly instead, and I can let you do that one on your own, then this guy would be one time and one time, and there would be a bigger difference than 491. But because daily and continuously are closer together, we can see that there's not that much difference in how much we would earn.